In addition to discussing the derivatives of exponential functions, section 3.3 also discusses the inverses of trigonometric functions. We'll start with the example of y is equal to sine inverse of x. We'd like to find dy dx. This technique can always be used to find the derivatives of inverse trig functions. So let's start with, if y is equal to sine inverse of x, let's apply the sine function to both sides. So on the left side, we'll have the sine of y is equal to, on the right side, the sine of the sine inverse of x. Now remember the property, basically the property of the definition of inverse functions is that they're functions who compose with one another to form the identity. So if f composed with g of x is equal to x, and g composed with f of x is equal to x, then g is equal to f inverse. All right, so since sine and sine inverse are inverses of one another, roughly, all right, they compose to form the inverse. So this is the same thing as x is equal to sine of y. Okay, now let's take the derivative. We're looking to find dy dx, so let's take the derivative of each side with respect to x. So on the left side, we'll take the derivative with respect to x of sine of y, and on the right side, we'll take the derivative with respect to x of x. When we do this, okay, on the left side, remember y is a function of x, so sine of y is really a composite function, so we have to use the chain rule to take this derivative. And we take the derivative of the outside function. The derivative of sine is cosine. We evaluate that at y, and then multiply by the derivative of the inside function, y prime. And of course, the derivative of x with respect to x is simply 1. So we have cosine of y times y prime is equal to 1. Well, we're looking for the derivative of y. We're looking for dy dx. And so dy dx, I'll write that way. Dy dx, which is the same, of course, as y prime, is 1 over the cosine of y. Now this is kind of a strange situation. We started out with y being a function of x, and we've taken its derivative. We found dy dx, but now we have a function of y. All right, well, we know that y is equal to sine inverse of x, so this dy dx is going to be the same thing as 1 over cosine of sine inverse of x. All right, now these are not inverses of one another, so we can't just say that this is x. But if we think of sine inverse of x, sine inverse of x is like an angle. And if I would take the sine of the sine inverse of x, I get x. So the sine of this angle is x. All right. Well, let's see. Remember, the sine in a right triangle, the sine is the opposite over the hypotenuse. So this would happen if I would make the opposite side x and the hypotenuse 1. So if this side were x and this side were 1, then we'd have, this would be the sine, this angle would be the sine inverse of x, because its sine would be x. Well, if that's true, using the Pythagorean theorem, all right, we could find this remaining side. The remaining side would be, excuse me, remember, a squared plus b squared equals c squared. Well, a squared is what we're looking for. B squared is x squared. And c squared is 1 squared, or 1. So then a squared is 1 minus x squared, and a is the square root of 1 minus x squared. So this would be the square root of 1 minus x squared. Well, the cosine of sine inverse is a cosine of this angle, and the cosine is the adjacent over the hypotenuse. So the cosine of the sine inverse of x is just going to be the square root of 1 minus x squared. So dy dx in this case is 1 over the square root of 1 minus x squared. Let me write that. I'll write that in a moment. Here is, and I just want to point out to you, notice that this is always a positive number because square roots are never principal square roots are never negative. And if you look at, this is sine, the restricted version of sine, we just take the part from negative pi over 2 to pi over 2 because that part is 1 to 1, and that's the part that is inverted to form inverse sine. Notice the inverse sine, okay? The inverse sine always has positive slopes, all right? That's because its derivative is always positive. At the very ends, at 1 and at negative 1, okay, notice it would be undefined, and that's because its slope would be vertical at that point. So keep in mind, we have this formula now that the derivative with respect to x of the inverse sine of x is equal to 1 over the square root of 1 minus x squared.